Hey, it's Mr. Allred here, and we're going to do a practice problem with quadratics, but it's a word problem. So, what we've got here, it says a rocket carrying fireworks is launched from a hill 80 feet above a lake. The rocket will fall into the lake after exploding at its maximum height. The rocket's height above the surface of the lake is given by the function h of t, which is negative 16t squared plus 64t plus 80. So one thing you should kind of take into account here is that we are, assume we're like on a building or something, 80 feet up in the air. And there's a firework that's going to go off the building and go up, go boom, and then go into a lake over here, which is below the building. So here's the lake. And the building we said was 80 feet tall. And we said at the top of the building it will go boom. So boom, 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 boom. Okay. So think about this on an XY plane. The 80 that they've got for the height of where this thing is starting is kind of like the y-intercept. So that's why it has a plus 80 at the end of the function. And if you plug 0 in for t, you would get 80 back. That's your y-intercept. So let's see what type of questions they're asking us based off of this function. What is the height of the rocket after 1.5 seconds? Well, they tell us that h of t calculates the height. So all we have to do is plug this 1.5 into our function. Now we might need a calculator, but that's negative 16 times 1.5 squared plus 64 times 1.5 plus the 80 feet building that we started it on. So my calculator, it's going to take a moment. Let's see here. Hitting some buttons. And I get 140 feet. So after a second and a half, the firework or the rocket that we sent up is 140 feet in the air. Okay, so that's just a point on the parabola. Okay, B, what is the maximum height reached by the rocket? So they're asking us for the maximum, and remember that would be where this little guy turns around or reaches its highest point. That would be the vertex. Okay. And so remember how we calculate the vertex. X, or in this case t is our variable, is negative b over 2a. So negative b will be negative 64 over 2a will be negative 32. So the time that it reaches its maximum height is 2 seconds. Okay. But that's not the maximum height. So we have to come back and we have to plug in 2 to the function. So we need h of 2. So that would be negative 16 times 2 squared plus 64 times 2 plus 80. So I'm going to pick up my calculator again. If I'm not mistaken, I've got 144 here. I think I'm going to put that in again because I'm a little worried about it. Because in that half second it only went up another 4 feet, but maybe that's where it's just stopping its movement. So 4, so negative 64, so 80 minus 64 plus 128. Yep. So it goes boom up here. 2 seconds into launch at a height of 144 feet above the ground. Okay. So it took 2 seconds to reach that height, and you may start thinking that things are symmetrical and that it's going to take another 2 seconds to hit the ground. But remember, the thing didn't start on the ground. So it might take it another 2 seconds to get back to the 80-foot high building. But it may take longer to reach the lake. So it says, after how many seconds after it is launched will the rocket hit the lake? So that is like a x-intercept. Okay. Because we want a height of 0. So when it hits the lake, it's going to have a height of 0. It's not going to be 80 foot in the air or 80 feet in the air where the building was. It's going to come below that and hit the ground based off of what we got here. So at 0 seconds, the function tells us we were 80 feet high. Calculation says at 1.5 seconds we were 140 feet high. After 2 seconds we were as high as we'll go at 144 feet. So we're going to take our function and set it equal to 0 to find out when it hits the ground. So 0 equals negative 16t squared plus 64t plus 80. And I think I can pull out, for my factoring purposes, a negative 16. Let's see, that'll give me t squared minus 4t minus 5. So if I factor this t squared minus 4t minus 5, I get t minus 5 and t plus 1. So the answers there are t equals 5 and t equals negative 1. Well, first of all, t being negative 1 means negative 1 seconds. That doesn't make any sense, but if you think about that we started at 0 times 0, 80 feet in the air, and just kind of extended the parabola backwards, that would be before we ever started if the building wasn't there. But that negative 1 second doesn't make any sense. So after 5 seconds, it hits the ground. So, well, the lake. Lands in lake after 5 seconds. So we started on the building. It took 2 seconds to get as high as it would go, and then it took 3 seconds to go down below the building and land in the lake. So a total of 5 seconds from when we launched it, it lands in the lake. So using all the things we kind of talked about there, all that kind of ties together. You don't even have to graph it to do that, but it does possibly give you a little bit better understanding because basically we got a graph over here.